All right, so think about this tonight. Oh, now my OneNote's going to crash. How freaking exciting is that? All right, one moment, please, children. Mr. Grimm's going to restart the program. Delete notebook cache. I don't know what that means, but sure. Oh, yeah, I don't have any open notebooks. All right, cool. Let's create a notebook. Sure. Brother, what's a math notebook that I want? Math 321 Spring 26. There it is, dog. Bam. Oh, it's going to want me to sign in, but it can't. Oh, for God's sakes. You know what? Can I just stop it? How about just stop? How about just stop? This is retarded. Can I just have my... Can we open one? Would that be okay to open one? Yeah, I don't really care. Here we go. So we're just going to use this one, I guess. Whatever. Life goes on. So here's the game. We are going to do today chi-square... And my pen isn't going to work because, you know, obviously. Chi-square test for independence. Independence. What do we mean by this? So the other day we chatted about kind of like this. Hair color, blonde. Yeah. Brunette. Sure. All right. Redheads. Ah, there you go. Black hair, sure. Good enough for government work. This is from the factory color. Everybody goes gray eventually, and we're not talking red, purples and all that. We're talking factory colors here. You with me? Ain't no one come from the factory with purple hair. That's weird. Okay. And then brand of cars: Chevy. All right. Toyota. Honda. Ford. No, that's enough. I just want to do 3. Sure, why not? There we go. Is there any sort of relationship between these? I don't know. 17 chicks. There's 17 blondes drive Chevs, and 10 Toyotas, and 14 Hondas, and brunettes 22, 11, 19, 16. 12, 20. That's kind of odd. But it's whatever. Now watch this one. 2, 26. 3. Well, that's kind of weird, isn't it now? Now you look at that, you're like, it seems that the black-haired folks really like Toyotas. So here's our test. Our test is always H0, boom, boom. In this case, car brand and hair color are independent. H1, they are dependent. There's a dependent relationship. Hey, you're blonde, you must drive a Chevy. That's not what we're saying, bro. We're just saying there's a relationship here. Okay, now, this is how we're going to do it, all right? So, we're going to go into your giggle sheets, and I'm just going to put this into a table. And from now on, okay, what I want to see I want to see your H0s over there. For sure, man. Bro, let's go. Launch. Where's my... Can I please just have my... Judas Priest. Bro, whatever. Let's go. Oh, yeah, you gotta sign in on your doohoo, groom. All right. I said sign me in, dog. Let's go. One moment, please. Gosh, we're having fun, children. It's my fave. Dun, dun, la, da, da, da. Send me a push. All right, I pushed it. I pushed it real good. There we go. Now, we're going to go into the giggles as per usual. Here we go. And I'm just going to grab a sheet. Doesn't really matter which one. Let's go. Just make a new one. What have you. You can use the same one you're using for your homework the other day on the other one. I don't really care. All we're doing is this. So pay attention to this. Here we go. So what I'm going to do is I'm going to go blonde. That looks like something. I don't know what that is. Blonde. Brunette. Red. Black hair. Sweet. Okay, you with me? And then Chev. Toyota. Honda. Okay, and again, it's just made up numbers, so don't get all weirded out by where they came from. I made them up. I pulled them out of the usual orifice, as it were. Okay, so here we go. Minimize. So 17. Get over here, you dirty hippie. Oh, damn it. All right, 17. 10. Oh, why aren't you typing, you dirty hippie? Let's go. 17. 10. 14. 22, 11, 19, 16, 12. There's too many redheaded people. That's weird. Just kidding, Jilly. Don't get angry. 2, 26, 3. Okay. We gooch. So I've simply copied my table in. In the future, okay, there's a few problems in the book that'll have their own tables. And then we're also going to use some pivot tables, and I'll demonstrate that in a few minutes. And so we'll go from there. But here it is. So here's what I want you to do. This is how Groom does this. So a little Control-C. I'm just going to paste these titles here and Control-C here like thus. Control-C and huzzah. Boom. Now what we need what we call the column totals. You with me? So here I copied that and I just did the sum of each of those guys. Are you with me? So 56 Honda people, 59 Toyotas, etc., etc., etc. And then I'm also going to do the sum this way. So what I'm doing now is the row marginals. Okay? We are writing the sums in the margins, as it were. So column and rows. And then this is the grand mean, we call it, which is you could either sum up these 3 numbers or these 4 numbers. Either way, it's still 72. Are you with me? There's 172 people out here. Now, I'm going to add a row here real quick so you can see what I'm doing. Now, once you get the gist of this, it's so easy, okay? So these up here are your expected, they're your observed. That's what you saw happen. But Groom, how do I find my expected values? Okay, this is how you do it. Equals. Now for Chev, it's in this column. So we're going to take the total for that column. Now this is important. You must put a $sign. So you can either hit F4, and sometimes that will work for you. Maybe it doesn't. But irregardless, you need to put $6. What that does is it's going, when I paste it sideways and move things around, it's going to stay in column and it's going to stay in row 6. So when I drag it over to Toyota, it's going to go C, but it's going to always stay in column 6. Are you with me on that? So we're going to take that, which is the column, times his row amount, which is that guy. And we're going to hit F4, or we're just going to type in a $sign with the $sign in front of the E, because we always want that to stay in the column E, but we want to be able to move down 2, 3, 4 as I drag it down. Divided by the grand total, and I never want that one to change, so I want both $signs. Okay? So it's, if you look at it here, it's column times row divided by grand mean, or if you prefer, a grand total. You can also take row times column, but divided by grand. Okay? Now, it suggested this autofill. Let's see if we like it. Is that correct? Yes. So for redheads, it's taking this one because it's in the redheaded Chevs. We're taking the Chevy total times the redheaded total divided by the total, which is awesome. Now that we've done it correctly, we can then just drag it sideways. Oh, poop. We can drag it sideways like thus. Now, always double check yourself. Let's just click on one of these ones. You see this? So for this fella, this is the redheaded chicks, the redheaded people, I should say, who are driving Toyotas. So it's the total of Toyotas times the total redheads divided by the this is perfect. We did a good job, didn't we? So what we're going to do to find our values is this. Okay? I'm going to go equals, and I'm going to do parentheses, and it's going to be observed minus expected squared divided by expected. So that part is the same. The part that's a little different is how we find the expected values. So point whatever. Now I'm going to drag it down 1, 2, 3, 4, right? 1, 2, 3, 4. And I'm going to drag it across 3. 1, 2, 3. And now what I'm going to do is I'm going to take the sum, so equals the sum of this group of data points. And that right there, my friends, is my chi-square. This is my chi-square number. Okay? So equals, it's always an upper tail test, so 1 minus chi-square dot dist. Oops, poop. And so we click on this 42, done, comma, degrees of freedom. So it turns out, and I'll write this down in a minute, the degrees of freedom is the rows minus 1. So 4 rows minus 1 is 3 times column minus 1. So it's going to be 3 times 2, 6 degrees of freedom, and then comma 1. There's your p-value. What does that tell me? Over here, I'm going to reject h naught. So my p-value was, I didn't look, 0.000000001. Whatever. Reject h naught. There's a reject h naught. There or hair color and car brand are dependent. Okay, it's that easy. Now, again, your degrees of freedom is always, for this, degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So in our case, we had four rows. 4 minus 1 is 3. 3 columns. 3 minus 1 is 2. 6 degrees of freedom. Now, what if we come back over to here, and what if we open a new spreadsheet, but not a new one? Let's look at an old one just for a good time. Wait, Groom, we should do one that has, what is all this? Isn't my stuff. Oh, what about this pivot table one, bruh? Let's look at this pivot table one, bruh. So Groom is going to enter a pivot table like we did before. Are you with me? Boom, done. Oops, come back, you hippie. All right, whatever. There they are. So I'm going to insert. No, I'm not going to insert. I'm going to go data, create a pivot table. Where's it at? Pivot table. Where's pivot table? Damn it. Why can't I see pivot table? Am I stupid? Insert pivot table. That's where it should have been all along, you idiot. All right, here it is. So Groom wants to know is which parent you live with. Which of these parents, like, does whether you go to prom depend on whether you live with one parent or the other? Are you with me? That's what I want to know. In other words, most people that go with the prom live with both parents. Okay, I don't know. I just made that up, so don't get all weird, okay? Maybe that's true. I don't know. So these people live, both parents, mom, dad, other, what have you. Okay, live with grandma. Now, let's put going to prom on the columns. Dude, how exciting for us. So look, there's 4 choices here, 2 choices here. Groom, it even gave us the totals. Bro, I know. Check this out. This is where it gets awesome. Because if you use a pivot table, which I just did, okay, what I can do is I copied that pivot table, and I can come over here and I can paste values only. Are you with me? Now, Groom is going to copy Control-C, Control-V, and Control-C. Actually, you know what I'm not going to do, though? I'm not going to put that grand total business because that kind of weirds me out. How about that? Huh? Boom, done. So check it out. Check it out. So it already did this. So these are my observed. Let me highlight them for you. Those are my observed values. You with me? And they've been observed. Now, down here, I'm going to create the expecteds. So to do the expected, I take the column that these guys would see. These are all the I'm not going to prom people. I'm going to either hit F4 a couple of times until it stays with a $sign of 6, or I'm literally going to type B $6 times. And then I'm going to click on the row total for both because I'm talking about both parent ones. I hit F4 a couple of times until it's in front of the D, or in other words, I type $D2. Divide by the grand total. You with me? And hit F4 once, or $D $6. Let's autofill it. Let's verify that's correct. So we're calling the right column and the right row for mom. That's hot. Now, grab this. Oops, grab this. And drag it over. Ta-da. You with me? Those are the expected values. Well, now we need to compute our function. So it's parentheses, observed minus expected squared, divide by expected. Mr. Groom, that is a tiny number. Well, that's because 47 and 48 are pert near the same number. In fact, if you're looking at these all match up pretty dadgum close to what we thought they should be, huh? So what does that tell me? It tells me that when I do this, I get a bunch of tiny numbers. Wait, but Groom, so if I take the sum of this set of numbers, my chi-square number is going to be pretty small. In fact, that's redonkulously small. So if I do equals 1 minus chi-square dot dist, this fella, and I click on this guy, and now my degrees of freedom, there are 4 rows. 4 minus 1 is 3. There's 2 columns. 2 minus 1 is 1. 3 times 1 is 3, comma 1. Bam. There is a 98% chance that we saw what we saw. Bro, what does that tell me? I'll tell you what that tells me. Fail to reject H naught. What does that mean? It means whether you go to prom or not has nothing to do. It's independent of which parent you live with. See? Isn't that cool? Nice. Now, what if these two were asked backwards? 63 and 32. Okay, does that change it? Well, now listen. Does that change things? Yeah, a lot. Whoa, that's a big difference. Oh, look at your p-value, dog. 0. Why? Because in this instance, for whatever reason, the kids that live with mom only in large numbers do not go to prom. But why? Bro, I don't know. No one paid me to answer that question. They simply wanted to know, in this instance, is there a difference? Or is, in other words, and so maybe why? Maybe because Freshner wants to get more kids to go to prom. She realizes that the kids that only live with their moms hate going to prom. And so she is going to have some outreach. I don't know. I'm not in leadership. So I don't know. I couldn't tell you. Okay. Let's come back over to this dog here. Let's do a different one. All right. So get rid of this. Mr. Groom, is there a relationship between what grades the children is in and what math class they're in. Okay, is there? And the question is, I don't know. Remember, we're going to make this count. We're going to make it count because it counts 10 as a number as opposed to how many 10th graders there are. Does that make sense? So in this case, you'd be careful of that. And what math class we're in. Now, in a perfect world, would there be a difference? There sure would be a difference. In this case, Mr. Groom just made this data up one day because he was bored, and so this may or may not be true. Maybe we're at Jesuit and there's a lot of smart kids. Well, that doesn't make sense. A lot of dumb kids in this table. I don't know. We're somewhere. It's hard to say. In a perfect world, you'd be like, Groom, I feel like more freshmen should be in Algebra 1 or what have you, right? But I don't know. It's like there's a lot of freshmen in calculus. That's kind of stupid. You with me? That's kind of stupid. Okay, but let's just pretend this is true. I don't know. I just work here, for now. And so Control C. I just paste these down here because it helps me keep track of who's who. You with me? That's all I'm doing. Boom, boom, boom. Control C. Control V. Paste. Done. Awesome. You with me on this? Piece of cake. Now, we already have, again, our grand totals and our totals because it's a pivot table. That's literally what a pivot table does. So to find my expected value, it's equal. My expected value is going to be equals to the column total, F4 a couple of times, times the row total, F4 a couple of times, until it's in front of F, divide by the grand total, and F4 there. Again, whatever has a dollar sign in front of it will not change. And so, no matter what I do when I drag the formula, this will always stay F6. This one, I can drag it sideways. It will become C6 and D6, but it will not change from being 6. Okay, when I drag it down this column, it'll always stay in row 6. And ditto on this side over here. This one's always going to stay in column F. You see that? Column F2, but the next one's going to be F3 and so forth. But it's never going to move from column F. Okay? Hit enter. She wants to autofill. That's hot. If you look at this, that is the correct line. So yay, we did it correctly. Grab these guys and drag them sideways. If you're just, perusing the data, you're like, Groom, this is 20. That's 19. This is 16. That's 19. Yeah, whatever. 17, 18. Is there a little bit of difference? Well, there's little differences, but not tons of differences. Is it different enough? Bro, I don't know. That's why we're running the test. Literally, that's what we want to know. Is this wildly different enough to say, without a doubt, that this thing is different? And the only reason it's different is because of our expected values are too far off from our observed values. So observed minus expected squared divided by expected. See, that's a tiny number, bro. Now drag it out. 1, 2, 3, 4. Those are all tiny. Drag it sideways. Geez, those are all tiny. Let's take the sum of those guys. Holy cow, that's a tiny number. So equals 1 minus chi squared dot dist. And, what are you doing? Of this guy, attaboy, comma. Now the degrees of freedom. We had 4 rows and 4 columns. 4 minus 1 is 3. 4 minus 1 is 3. 3 times 3 is 9 degrees of freedom. Oh, Judas Priest, what's your problem, you dirty hippie? What? Oh, I clicked on chi. Oh, you jackass. Let's try this again. 1 minus chi squared dot dist. Now, if you click on the right one, it probably will work, Groom, you moron. So, comma 9, comma 1. Huzzah! There's a 67% chance that this happened. If H naught is true. What's H naught? These things are independent. So, you fail to reject H naught. So, at this stupid school, it doesn't matter what grade you're in. There's going to be an equal distribution or the same distribution of kids in every class. Algebra 2, pre-calculus, calculus, etc. Again, that's ridiculous. There have hardly ever, I think I've had maybe one sophomore in calculus, maybe two over the years. There's not many. Never a freshman that I've been aware of. Is it possible? I suppose, but really not. Ditto with stats, right? Pre-cal, you'll see a few sophomores in pre-cal, sure, of course. Algebra 2, you'll see some freshmen in Algebra 2, of course. But generally speaking, there's way more higher percentage of juniors and seniors in there than there are freshmen and sophomores. And so as a result, a normal school, you would see a big difference. And what would that tell you? It would tell you that there is a relationship. That is, they are dependent. Okay, but this one here, failed to reject, they're independent. Okay, that's it. That's all we did. That's it. That's it. And so you may recall from this is the last one. You may recall, I believe this one had ice cream. And put that on the values as well. Boom. And on columns, let's put feeling about running. And you're like, oh, yeah, that's right. And I feel like Groom did something with strawberry on this one. I feel like he did too, but I don't remember what it is. So let's go and create this deal and see what's up. Now, do you know anything that stands out to you? Wow, there's a lot of people who hate running that like strawberry ice cream. Is that weird? A little bit. Is it weird enough for it to be a dependent relationship? No, I don't know. We'll find out in a minute. That's why we're doing a test, bruh. That's why we're doing a test. Sit tight. You'll see in a moment. Now, boom. There was a problem, Mr. Groom, you stupid buffoon. There you go, dog. Boom. Now, equal column total. Boom. F4. Boom, boom. Times row total. Boom. F4. Couple times. Divide by grand total. Boom. Hit F4. Done. You want me to autofill for you? Sure, man. That'd be great. Thanks. Is that correct? That is correct. So, grab this and drag it over. Those are already pretty good sized numbers. You with me? So, wait, hold on before I back up. 5.9, 5. 2, 4 is pretty close. 2 and 3 is pretty close. 13 and 11, that's pretty close. 4 and 4, yeah, okay. These are all fairly close numbers, yes? Except for, perhaps, but you're like, no, Groom, that says it should be 82. It should be 85, and it's 82. Well, maybe we're not off, Groom. Well, there's only one way to find out, dog. So equals percent equals whatever that p word is, parentheses. So we're going to go observed minus well, hold on. I almost screwed. No, I did right, you dumbass. Observed minus expected squared divide by expected. Drag it down 5 places. 1, 2, 3, 4, 5. And then drag it sideways. Boom, boom, boom. Done. So equals sum. Now, if you look at these numbers, none of them look ridiculous, do they? Not one of them looks ridiculous, really. And so I got 6.6 again. Now, is that a big number? No, not really, but we're going to find out in a minute. Chi-square dot dist. Oops. So there's my critical value, my chi-square value. So there's 5 rows. 5 rows. So 5 minus 1 is 4. 3 columns. 3 minus 1 is 2. 4 times 2 is 8 degrees of freedom. And so you got a p-value of 0.57. The idea here is what? Is there any relationship between the kind of ice cream you like and whether you like running or not? Absolutely not. They are completely independent. Fail to reject H naught. These things are independent of one another. All right, have a good time.